My name is Dylan, a student reporter with Invention Convention Worldwide. I'm excited to introduce my guest, Dhruva, an 11th grader from Florida. Dhruva's most recent invention, Flow, uses machine learning to improve traffic efficiency without requiring costly infrastructure changes. This project won first place in 10th grade and the Transportation Industry Award at the Invention Convention U.S. Nationals 2023 competition. Welcome, Dhruva.
Thank you for having me.
So, Dhruva, before we get into more details about your project, tell us a little bit about yourself.
So as you mentioned, I'm in 11th grade. I have a passion for STEM. I love doing robotics. I'm on a robotics team called Java the Huts, and I really enjoy every aspect of STEM. This year, my project for Inventor is similar to my previous project, Flow, from last year. I've just expanded on it and furthered that idea of improving traffic with artificial intelligence. It's something I'm very passionate about, the intersection of machine learning and traffic optimization. So I've pursued that project further, and I'm hoping to take it further this year.
That's really cool. I'm also on a robotics team. So why or how did you first get into inventing?
My invention journey started in 7th grade when it was a school-based fair and everyone was required to participate in it. But that first fair really sparked my interest for the invention process. And since then, ever since 7th grade, I have been an avid participant in both science fair and inventors fair at the local, state, and national level for the past 4 years. And it's been a big part of my life. I just love the process of having an idea, or first identifying a problem, and then coming up with an idea, and then bringing that idea to reality, and prototyping and iterating and innovating, and having a tangible product that actually solves a problem that can benefit someone's life. That, to me, is just extremely rewarding.
I was looking over your project and it looked really interesting. So do you mind telling us about how you came up with your problem and dive deeper in how you designed your product?
Sure. So a brief overview of my project. It's an artificial intelligence model for improving traffic regulation. So in this current day and age, there are many inefficiencies in just standard traffic scenarios that many streetlights are regulated through a timer system, so they're time-based. They're not adaptive or intelligent by any means. Some do take in data of the number of cars in each lane, but again, they're not intelligent in terms of artificial intelligence. They're not adaptive like that. They either scale the time of the lights based on the number of vehicles. So a greater number of vehicles would result in a longer green light, shorter number, vice versa. But they're not adaptive. And that's where I targeted my solution by incorporating artificial intelligence into the standard traffic lights you see every day. And I identified my problem. I was in Boston, Massachusetts, visiting colleges, specifically MIT, and Boston is renowned worldwide for horrible traffic congestion. I think it's number 3 in the world for the worst traffic, or number 3 in the U.S. for the worst traffic. And that just really, it bothered me that it seemed like such a simple problem to solve that should have been solved before. So I spent the rest of my summer researching, looking into that problem, and I met with my local Department of Transportation that same August, last year, and I had spoke with them about this idea, and after speaking with them and gaining inspiration from my project, I decided to pursue that because they really showed me what the current traffic regulation methods are that are in place today, and the extent to which they lacked intelligence really surprised me, and I wanted to do something about that problem.
I actually live pretty close to Boston, so in my town, especially when school gets out, it's really time-consuming to navigate through traffic. So do you mind talking about how you marketed or licensed your project out to different communities for them to use?
So right now, my project Flow isn't, it's not in a state where it can be used in the real world, but I have a plan to reconnect with my local Department of Transportation and actually present my simulation run the machine learning models on traffic simulations, compare the accuracy or uh, the average wait. So the way you measure the performance of the model is through the average wait time each car spends at a light. So uh, the the time it takes for a car to get past the red light is how you measure the efficiency of the model. So compare the efficiency of the artificial intelligence model to the efficiency of the models that are currently in place to regulate traffic. See the percent increase in efficiency and determine whether or not that the infrastructure that's required to implement a model like this is already in place. So that's why there's not much cost associated with this product. And to see if the idea of implementing this would be worth it in a real world scenario. So pursuing that connection with my local Department of Transportation would definitely be the next step to see if this could be licensed or marketed to the next level.
I know inventing can be a long process, especially since you were speaking to your Department of Transportation. So when did you start this process, and how many iterations or versions of this final product did you make?
I started my product actually prototyping in about August. I had identified the problem the summer prior, and I had went through about 4 different iterations. So as you can imagine, since it's an artificial intelligence model, there's no physical prototype. It's all just lines and lines of code, and that translates to a simulation which you run a traffic simulation, and that traffic simulation is then controlled by the artificial intelligence model. So I went through 4 different iterations of that said artificial intelligence model, modifying the architecture of it, identifying different hyperparameters, basically optimizing it so that it could better regulate traffic. So 4 different iterations before I was satisfied with its performance. And in the end, I achieved about a 67% increase in efficiency or traffic regulation efficiency compared to a standard time-based system that's currently in place today.
So among these iterations, what are some of the largest challenges you had to overcome in order to get this really good result?
So the biggest challenge that is associated with any traffic regulation project is the accuracy of the data you collect, because if you're feeding the model data that's not resembling the real world, for example, if you use a camera to detect vehicles on the road and the camera doesn't accurately detect the number of vehicles or the position of the vehicles, or where the vehicle is, then it's going to input faulty data into the model, and the model would uh, result in an unoptimized output for the real world scenario, because the accuracy of the data isn't where it needs to be. So the biggest problem to overcome is the accuracy of the data, and to solve that, you need to use machine learning models to capture images from the traffic cameras and then analyze it in real time, translate that into position data for each specific vehicle, and then input that into the model. And that was the biggest step to overcome, because if your data is not accurate, your model is not going to function.
Are there any more of these challenges that you're still facing with your project?
That was the biggest challenge to that I faced, was the accuracy of the data, and I successfully overcame that through the implementation of an OpenCV algorithm that just in real time it takes the cars, it subtracts the background of the road, and it has parameters to adjust for different lighting conditions, different weather conditions. So it's adaptable to almost any scenario, any location in the world, and it extracts the features, and in this case the features are the cars or the vehicles, and then it determines the velocity and the momentum of the vehicle to predict where it's going to be, and it determines the current position of the vehicles, so where it is at the specific point in time, and that information then gets fed into the machine learning model, and the machine learning model learns from that data to optimize the traffic patterns to minimize the average wait time of every individual vehicle.
This seems like it could be really useful in a lot of different communities, so do you have plans to patent your current design?
Yes, I do. I'm currently in the process of filing a provisional patent. Since I've been working on my project again, furthering it this year. I'm actually in the process of applying for a provisional patent, and I'm waiting to hear back from USPTO to see if they have accepted my application. If if it does get accepted, the next step would obviously to be apply for a utility patent, and that would be the end goal. But that's the hope, to eventually get a patent on this product.
So throughout all this whole process, what was your favorite part?
I think my favorite part was definitely speaking with my Department of Transportation, because it was really cool to see what they were able to do. How many different systems they have to manage something that we all take for granted. We just drive on the road, but we don't really see what goes on behind the screens. How much effort they put in to make sure that we're able to get from point A to point B safe and sound, and how quickly we're able to get there. We take for granted a lot of what happens behind the computer, and it's really cool to see what they're able to do. And that was ultimately what inspired me to do my project, was seeing what they do and seeing how it can potentially be improved.
So you mentioned that you are currently working on improving your current project. So what does that look like?
Yeah, so in my previous project from last year, I focused on controlling just a single traffic intersection that had four lanes at a single intersection. And while this may be, it may be, it seems it's still difficult to control, to train a machine learning model to optimize that. But in reality, when you imagine a much larger traffic network and a much larger traffic grid, you have multiple different intersections all over the place interacting with each other. And you can imagine that decisions made at one specific intersection affect the traffic flow at a different intersection, and decisions made at like intersection and maybe in the top right of the grid would ultimately affect wherever that traffic flow is directed towards. So instead of focusing on controlling a single intersection, controlling a much larger network presents an exponential growth in terms of computing power and optimization challenges, because of that problem I described, where decisions made at one intersection affect every neighboring intersection. And to tackle that problem, the best approach that I found was a more decentralized control. So in my previous project last year, it was a single machine learning model controlling a single intersection. And you might imagine that the best approach would be to use a single machine learning model to control multiple intersections for the next year project. But that's actually not the case, because of that decentralized approach that's required for a problem of this magnitude. If you have a single model controlling 50 different intersections, it's going to take an improbable amount of time to optimize that, and it probably would not succeed in the real world. So using a singular machine learning model for each single intersection, and then having a second, much larger model overseeing every single intersection model, that's a sort of decentralized approach where it's not centralized or localized at a single model. Everything is spread out. That is the biggest and most efficient way I found to optimize this computational problem.
I can tell you put a lot of work into this project. So what advice do you have for other inventors that may be hesitant about pursuing a project?
I think the biggest advice I have is to just get started in it, because I mean it seemed extremely daunting at first. I didn't have any experience when it came to machine learning or artificial intelligence, or programming a machine learning model when I started my project. The first thing I did was I met with my Department of Transportation and I spoke with them, not knowing I would even be able to create a machine learning model. I identified the problem and I figured out exactly what my path to success was, and then I just kept at it. I mean, every small step you make is a step towards your final product, no matter how small it is. And that's the key, is to just really always make iterations and fail as fast as you can, right? Because if you want to know that you have a problem in your prototype as soon as you can, so that you can fix it as soon as you find the problem. And so that's really a philosophy that actually my robotics team likes to live by, is fail fast. Is you want to identify your problems at the very beginning and solve those problems at the very beginning so they don't become pertinent over time, and you're able to iterate as fast as possible.
So throughout this process, is there anyone that you would like to thank or help for guidance?
As I've mentioned a couple times, I'd definitely like to thank the people at my local Department of Transportation, because they definitely gave me a lot of support and guidance through this project when it came to understanding the current traffic regulation methods. And then, of course, I'd like to thank my parents, because they make what I do possible. They support me in every way possible, and it's because of them that I'm able to find my passion in STEM and pursue it in avenues like the Invention Convention.
Is there anything else you would like to share with the audience?
Any project that any inventor does is impactful, and what I've learned from this project is extremely inspiring. And I really plan on further researching the implementation of artificial intelligence and the intersection of artificial intelligence and traffic. And there's just so much to do in this field, and I hope to positively contribute to this field in the future and really make an impact on people's lives. Thank you so much for having me.
On behalf of all of us at Invention Convention Worldwide, thank you, Dhruva, for joining me. Be sure to check out other student inventor interviews on our YouTube channel. Until next time.